Okay, hi everybody. This is Jenny Rodin sitting here with my dad in his den, and I was asking him about the difference between mass and volume because I have not taken physics in a really long time, and it came up in calculus class. And so he had a really good way to explain it. So here he goes. Oh, Dad, you want to introduce yourself? Hello?
Hi everyone, I'm Dick Rodin, former chemistry and physics teacher for a number of years, and happy to be with you. Jen was had some questions about, as she just said, mass and volume, and they figure into the term called density. Probably heard that. And a cubic centimeter of water at room temperature is a sort of standard for mass, because a cubic centimeter of water at room temperature has a mass of a gram, a hundredth of a thousandth of a kilogram. And this is all good and well at room temperature, but if you change the temperature of the water, it's still a gram of water, but if you make it warmer, it expands. And if you do that to the extent that it will freeze, it's expanded quite a bit, enough that water in pipes sitting idle will break the pipe as it expands, or at least it'll crack the pipe. And then when the water is turned on and is running, you have a leak. And this is all because of the expansion with temperature. It's also then, if water has a greater volume at higher temperature, this gram of water is going to take up more than 1 cubic centimeter. Still a gram of water, but it's now bigger. And so its density, weight per unit volume, as the volume gets bigger, the weight per unit volume is going to get smaller. And water and ice at different densities, and ice having the lower density, will float. In fact, anything with a density less than 1 will float on water, and so ice floats. And it's fortunate in a way that that's the case, because in the winter, when it gets quite cold, if ice was like most substances and got more dense when it hardened, it would sink to the bottom. And then in the spring, it would take it by the end of summer before it kind of melted. It would be, ponds would tend to get literally frozen solid if the ice sunk. But fortunately, it floats on top, and so we can skate on it and have hockey games. And this is a little confusing when you try to connect it with the English system, which uses the pound as a unit of, well, let's say weight, and weight is, the attraction of gravity for an object, the force of attraction. And so they talk about a 20-pound weight as a thing that has a mass of 20 pounds and weighing 20 pounds. And this kind of is
Confuses me.
This is confusing, yeah, because it's you have to say, well, now they say here, this is 20 pounds, and you really should say, well, do you mean it has a mass of 20 pounds or it weighs 20 pounds? Because they're not the same. They can be the same, but they're not guaranteed the same.
Because your weight would be different on the moon, right?
Yes, on the moon, you are still, whatever your mass is here, you just have that same mass on the moon, but it would be less attraction because the moon doesn't pull you down as hard. And so the force of attraction is less, and your weight would be less. It's,
Okay.
okay?
That makes sense. I think we're good. We covered it pretty well, right?
Right.
All right. Thanks, Dad. You want to say goodbye to the viewers, or are you good?
I could add one more.
Oh, go ahead. It's only been 4 minutes.
The idea that on the moon you weigh less, you would probably feel that if you're walking around, but I had occasion to talk to Buzz Aldrin in a meeting some time ago, and he said, you forget that if your weight is less, it doesn't mean that you are less in mass. And your inertia, if you're like running, is a function of your mass and your velocity. And so you have less inertia if you are, you would have less inertia if your mass was less. And you tend to think that because you feel that you weigh less, and you don't notice that your inertia is the same on the moon. If you're running or turning around in a quick circle, it is very confusing because your mass is the same as it was here, but the effect of movement is not the same on the moon. The effect is less. You can't get going as well or stop as well
Huh.
if you're on the moon.
I didn't know that, Dad.
Oh yeah.
Oh. All right. Well, thanks.
Good luck, everybody. If you have any questions, ask Jen, or you could ask me. Send me an email or something, and I'll try to answer it for you.
Awesome. Thanks, Dad.